What I wanted to talk about is something very specific that MEI is doing at the moment, which is looking at implementing a new unit as part of the current assessment regime that will involve some computer-based maths. Just to give you an indication of where that unit will be, and I'll speak about why in a moment, but basically it will be a unit as part of further maths. For the benefit of people here who aren't from England, Wales and Northern Ireland, we have A-level maths, which is taken by about towards 20% of students pre-university level, and then there is a second higher level qualification which we call further maths. The Further Maths Support Programme was a programme set up in 2005 to increase the uptake of this second higher further maths A-level, and you can see from the graph there that's the actual numbers of students. So it is something that's had a real positive impact in terms of the high-level maths taken by pre-university students in England. And I don't know if you can read the figures, it's a bit too small on the horizontal scale there, but basically, as I say, we started in 2005, and we've seen well over 100% increase in the number of students taking this unit. So we're looking at putting a unit in there that will be assessed and learnt by a computer-based model. Now, why is it important to think about the assessment? And obviously, this session itself is about the assessment. Well, as Alison Clark-Wilson said, and I think many other people have indicated, teachers feel a great pressure on them to focus their teaching on the assessment. We could debate that for days on end, whether that's right or wrong, but it is the case that teachers feel that pressure. An example of that is, and any of you who were teaching in English schools between 2000 and 2004 will probably remember this, that a restriction was placed on graphical calculator use in about 2000, and the impact of that in A-level pre-university classrooms in England was massive. I was teaching through that period. Prior to that, it was easy to encourage students to have a graphical calculator. You may or may not like them, but they are a valuable piece of technology. It was easy prior to 2000 to encourage students to get a graphical calculator. Between 2000 and 2004, it was incredibly difficult purely because the assessment had restrictions on their use. So that is just one example, and I'm sure many of you can think of others where the assessment actually drives what technology teachers and students will use in the classroom. So we're looking at a unit that will assume students have a graph plotter, a spreadsheet, computer algebra, and also a programming language. In terms of the topics students will be studying, because of, we're talking about an incremental change here, and this is in no way saying that a revolutionary change isn't desirable, but this is saying the incremental change that we're looking at the moment. Because of where we are needing to put the unit, we're needing to find new maths that students aren't currently studying as part of the curriculum. So we're exploring these topics. These aren't set in stone yet, but we're looking at things like investigation of curves and investigation of equations, Fourier series, something using spreadsheets and computer algebra to really investigate limits, because I think pre-university students, certainly in England, don't get onto that as much as they could, and also some number theory. Now, to give you an example of one of those, the top one there, investigation of curves, is something that is currently assessed in one of the units at A level. And I think it's useful to have an example just to hang the general thoughts on, really, which is this example here, not to go into too much detail, but basically you've got a line of length k, you know it goes through 1, 0, you know one end is attached to the y-axis. What's the locus of the other end as that line is moved up and down the y-axis? But then crucially, what would happen if the length of the line varied, if you had different values of k? Well, a paper and pencil approach to that would be incredibly difficult. It's very easy with some form of software to set up a model, to have a look at the shape of the locus, and then to vary k. Here I've got an example of looking at two different forms of the equations of what the locus might be, but there's a slider on there. This isn't a dynamic version, but I'm sure you can imagine this is from a dynamic version where you can vary k. So the crucial thing, though, is that what's on the left there is a genuine example of a A-level exam question that some students have actually sat, and that's the type of thing we're looking at. This will be, in a sense, a traditional written paper. It's something where students will be given a written mathematics paper that they have to submit a written answer to, but the assumption is that to get that answer that they will have used some piece of software, have done some computer-based maths to actually get to the answer. And the reason for that is that that's achievable in terms of where we are in the current assessment regime. Just to finish off then, it's been mentioned in the last session, and it is vitally important, I think, that we're going to look at working with teachers. We're aiming towards the first assessment of this in June 2013, so we're going to be working with teachers this year for them to begin teaching the unit from next year. And it's key to us, and we think good assessment, good curriculum development has got to involve the experience of students and teachers. So we're hoping that through working with them, that will inform how this unit develops and what it actually finally looks like. And the last thing to say is I realise that what we're doing at the moment is at the top end in terms of the mathematics students. The reason we're doing this, as I said, is because that's where the opportunity lies at the moment. I am conscious that a criticism of this is something, my mother was a teacher, and something she always says to me when I talk about what I'm doing is that it's easy to prove anything with bright kids, and I think there is a case that's true. But I think what we really want from this is that when, it's not if, I think it's when there is a review of the A-levels in England in the next few years, that because we will have implemented this and because we will have a concrete example of how computer-based maths could work within the current assessment regime, then that would inform a wider integration of computer-based maths for many students in the A-level that's taken by a much higher proportion of them. Thank you.
Thank you.